Good day, math learners. Today, let's talk about defined terms. Now that the undefined terms are established, these terms, together with other non-technical terms, will be used to define other geometric terms. In defining a term, the following guidelines must be observed to construct a good definition. Number 1. Use simple, commonly used words together with geometric terms that have been previously defined or accepted as undefined. Number 2. Include only essential properties of the term being defined. And 3. Compose a reversible definition. Now let's start with definition of a segment. Now segment AB, denoted by segment AB or segment BA is the union of points A and B and all the points between them. A and B are called the endpoints of the segment. So for example, I have here segment AB. Alright, so the endpoints of this segment are the points A and B. And this segment AB is denoted by this one. Segment AB, or it can also be segment BA. Alright, now let's have another example. Now what if we have this segment, and this time the endpoints of our segment are Y and Z. So still the same, in denoting this segment, we'll have it as segment YZ or segment ZY. Okay, now remember, segments are portions of a line that has definite endpoints, and segments are named according or denoted according to their endpoints. So we know that if we have segment AB, then the endpoints of segment AB are points A and B. And if we have segment YZ, then we know that the endpoints of segment YZ are points Y and Z. Okay? Next. Definition of collinear points and coplanar points. Now, when points are on the same line, they are called collinear points. So, for example, if I have a line here, and on the line lies point A, point B, and point C, then point A, point B, and point C are collinear lines. Again, they are called collinear lines because they are lying on the same line. Now, if I have another line here, and this another line contains the point D and E, points D and E are also collinear lines, collinear points, because they are located or they are lying on the same line. But points A and point D, they are not collinear because they are lying on different lines. Clear? So point A, point B, and point C are collinear because they are lying on the same line. Point D and point E are collinear also because they are also lying on the same line. Point A and point D are not collinear because they are lying on different lines. Same with point B and point E, point C and point D. Clear? Alright. Next, let's have coplanar points. Now, when points are on the same plane, they are called coplanar points. Now, in geometry, plane is mostly represented by a rectangle. So let's have a plane here. Now let's name this plane as plane X. Now plane X, okay, contains the points A. Okay, let's use another letter. Let's have point R and point G. Okay, now since point R and point G are located on the same plane, then meaning to say they are coplanar points. Now if I have here another plane, and let's name this plane as plane Y, and inside plane Y, we have their point Z and point J, then point Z and point J are also coplanar points because they are located on the same plane. But point R and point Z are not coplanar because they are located on different planes. Clear? Alright, let's have another example. Alright, I have here plane U containing the lines containing the points X, Y, Z and points K, L, and of course point M. Now, point X, point Y, and point Z are collinear lines because they are lying on the same line. Point K and point L are also collinear lines because they are located on the same line. Now, point X and point K are not collinear, but point X and point K are coplanar lines, coplanar points, because these points are located on the same plane, which is the plane U. So meaning to say all the points that we have here inside plane U are all coplanar points because again, they are located on the same plane. So point X, point Y, point Z, point K, point L, and point M are coplanar points. Okay, next. Let's have the definition of betweenness. Now, point V is said to be between I and Y if and only if I, V, and Y are distinct points of the same line and segment IV plus segment VY is equal to segment IY. Now let's illustrate that. Okay, so I have a segment here, and it says here point V is said to be between I and Y. So I and Y are the endpoints of our segment, and V is said to be between I and Y. So anywhere as long as it's between I and Y. So let's have it here. So point V is located on that point. Now, point V is said to be between I and Y if and only if I, V, and Y are distinct points of the same line. Now we just have here one line segment, and I, V, and Y are distinct points of our line segment here. Okay, so V is between I and V since we know that when we add the distance from I to V and the distance from V to Y is equal to the distance from I to Y. Again, the distance from point I to point V plus the distance of point V to point Y is equal to the distance from point I to point Y. Alright? That is the definition of betweenness. Now, let's have the definition of a ray. A ray is a part of a line that has one endpoint and goes infinitely in only one direction. Now, you cannot measure the length of a ray. So, a ray has one endpoint and its other side, is extending infinitely. Now, the endpoint of a ray, let's have this one as point A, and let's have another point on this part of a ray, and let's say this is point C. So these 2 points determine the name of the ray. So the name of this ray, or we denote this ray as ray AC. So writing, we have ray AC. Alright, so if I have another ray here, let's have this ray, wherein the endpoint is point E, and this part is point J, then the name of this ray is, or to denote this ray, we have ray EJ. Okay, so let's have another example. How about this ray? Ray, the endpoint is X and the point here is B. So how do we denote this ray? Of course, that would be ray XB. Okay? Next, let's have the definition of an angle. An angle is a unison of two non-collinear rays with a common endpoint. So, this is an angle. So, let's have our first ray, which is ray AB, and the second ray, which is ray AC. So, an angle is formed when two non-collinear rays have a common endpoint. So here we have ray AB and ray AC with a common endpoint at point A. So the angle that forms between these two rays, or the opening that forms between these two rays, called an angle. Alright? Next. Alright, let's have the definition of congruent angles. Now, two angles are congruent if and only if their measures are equal. So let's say we have two angles here. Okay, so we have here angle ABC, and we also have another angle. So this is angle, okay. Now this is angle ABC. And this is angle EFG. Alright? Now two angles are congruent if and only if their measures are equal. Now if the measure of angle ABC, to denote we write measure if the measure of angle ABC, this angle, is equal to 89 degrees, and the measure of angle EFG, this angle, is equal to 89 degrees, then angle ABC is congruent to angle EFG. Okay? Now, this is the symbol for congruence. So please write that properly in your works later on. Okay? And remember, when we denote the measure of an angle, we always write small letter m, okay, before the name of the angle. So we have the measure, and we read this as the measure of angle ABC is equal to 89 degrees. The measure of angle EFG is equal to 89 degrees. Okay? So if the measure of angle ABC is equal to 89 degrees and the measure of angle EFG is equal to 89 degrees, then angle ABC is congruent to angle EFG. Okay? So that is the definition of congruent angles. Now let's have the definition of different angles. So an acute angle is an angle with a measure greater than 0 but less than 90 degrees. Okay, so here is an example of an acute angle. So here I have angle ABC. Okay, this angle is an acute angle because when we use the protractor to measure this angle, then we'll get a measure that is greater than 0 but less than 90 degrees. Okay? Now, a right angle is an angle with a measure of 90 degrees. So, this is a right angle. So, this is angle EFG. Okay, angle EFG is a right angle because angle EFG measures exactly 90 degrees. And last one, we have the obtuse angle. So, an angle that measures greater than 90 degrees but less than 180 degrees. So, an example we have here. Okay, we have here angle HIJ. So angle HIJ is an obtuse angle because angle HIJ measures greater than 90 degrees but is less than 180 degrees. Again, let's have a recap. Angle ABC is an acute angle. Why? Because angle ABC measures less than 90 degrees but greater than 0. Alright? Now here, angle EFG is a right angle because angle EFG measures exactly 90 degrees. And angle HIJ is an obtuse angle because angle HIJ measures greater than 90 degrees but less than 180 degrees. Okay? Now let's proceed. Definition of adjacent angles. If angle ABD and angle CBD are adjacent angles, then they have a common vertex, which is point B, and the common side, which is ray BD. To illustrate, we have this one. Okay, we have here two angles formed by 3 rays. So we have angle ABD. So angle ABD is this one. Okay, that is angle ABD. And angle CBD is this one. Okay, so this is angle CBD. Now, we notice that angle ABD and angle CBD have a common or share a common vertex, which is point B, right? And also it has a common side, which is ray BD. So meaning to say, angle BAD or angle ABD and angle CBD are adjacent angles. But here we see that we have two angles also, angle EFG and angle JKL. Okay, but we see here that there is no common vertex and there is also no common side. Okay, the two angles are not sharing a common side. So meaning to say, angle EFG and angle JKL are not adjacent angles. So let's write it down. Angle ABD and angle CBD share a common vertex, which is point B, and also share a common side, which is ray BD. So meaning to say, angle ABD and angle CBD are adjacent angles. Okay, but angle EFG and angle JKL, since they don't have a common vertex and they also don't share a common side, they are not adjacent angles. Okay, now let's proceed. Definition of supplementary angles. Now, two angles are supplementary if their sum measures 180 degrees. So each angle is the supplement of the other. Supplementary angles may not be adjacent. Alright? To illustrate, we have here angle 1, which is equal to 140 degrees, and angle 2, which is equal to 40 degrees. Now, the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. So, meaning to say, angle 1 and angle 2 are supplementary angles. Okay? Now, we also have here angle 3, which measures 135 degrees, and angle 4, which measures 45 degrees. Now, if we add the measure of angle 3 plus the measure of angle 4, it will sum up to 180 degrees. Then, angle 1 and angle 2 are supplementary angles. Okay? So again, supplementary angles may not be adjacent. So, supplementary angles can share a common vertex and a common side, and can also not share a common side and a common vertex. Alright? Now let's proceed to the definition of complementary angles. So two angles are complementary if the sum of their measures is 90 degrees. Each angle is called the complement of each other. Complementary angles may also not be adjacent. Alright, to illustrate, we have here angle ABD and angle DBC. So angle ABD is equal to 45 degrees and angle DBC is also equal to 45 degrees. Now the measure of angle ABD plus the measure of angle DBC is equal to 90 degrees. Since the two angles sum up to 90 degrees, then the two angles are complementary. Same with angle 1 and angle 2 here. Angle 1 measures 40 degrees and angle 2 measures 50 degrees. Now, adding the measure of angle 1 and the measure of angle 2 will get 90 degrees, meaning to say angle 1 and angle 2 are complementary angles. Okay, next. Let's have the definition of a linear pair. So two angles form a linear pair if and only if they meet these conditions. A, they are adjacent angles, and B, their uncommon sides are opposite rays. To illustrate, we have here angle ABD and angle CBD. Alright, now these two angles are adjacent angles because they share a common vertex, which is point B, and also a common side, which is ray BD. Okay, so the first condition for a linear pair is satisfied or is met. Now, their uncommon sides should be opposite rays. Now, we can also see here that ray BA and ray BC are opposite rays. Alright, so meaning to say, the second condition for a linear pair is also met. So, angle ABD and angle CBD form a linear pair. And now, let's have the definition of vertical angles. Now, two angles are vertical if and only if they are non-adjacent angles formed by two intersecting lines. So, we have here line 1 and line 2. Now, line 1 and line 2 are intersecting each other, forming four angles. Now, angle 1 or opposite angles, angle 1 and angle 3 are vertical angles. Alright? At the same time, angle 2 and angle 4 are also vertical angles. Okay? But Angle 2 and angle 3 are not vertical angles. Okay? They are adjacent angles. So you have to remember that vertical angles are angles that are located on the opposite of each other. So we have here angle 3 and angle 1. They are vertical angles. And of course, angle 2 and angle 4, they are also another pair of vertical angles. Alright, I hope you learned something and see you in our next videos.